Hi everyone. The next session will be devoted to a particular knowledge graph, namely the transparency energy knowledge graph and advanced data validation in that knowledge graph using SHACO and some other constructs. So I'll first describe this transparency energy knowledge graph project, where it came from and what are the goals and who is the team. And then I'll describe the ENTSUI energy transparency portal, and it's quite important for anything that has to do with electricity in Europe. Then I'll be describing the TAKG data. First, I'll show you the specification that we have written, a rather comprehensive thing about the data that we assemble and the project and how it is going to be implemented and so on. Then describe the data items that the project works with, show some semantic models of some aspects of the data, and then we'll come to the gist of the presentation, which is about data validation, how we represent validation rules, how we use SHACO, how we capture the results from validation, then how the validation service is implemented, a little bit on external validation for VAT numbers in Europe, and then I will show the data quality dashboard or the UI application that we have implemented. And finally, I'll show you this slide. Okay, so this is a relatively small project that was won through an open call of the very large Horizon 2020 Europe project called Interface. Here's the logo of Interface, and you may have noticed that the logo of our own project is kind of made to look like this one. The goals of the project are to obtain some percentage of the data items from the ENTSUI Energy Transparency Portal. For those that don't know, ENTSUI is the European Network of Transmission System Operators. So the TSOs are the central entities in every country that operate the long-range transmission lines and also often the energy balancing and in some cases the energy market in the country. And so this transparency portal carries a lot of important information to ensure the transparency of the European energy market. Then within the project, we perform semantic integration of these items to build a transparency energy knowledge graph. We also integrate external data sources such as OpenStreetMap for mapping of geographic mapping of power plants through usage of some other power plant databases that provide correlation between identifiers. And we also do external checking of VAT numbers. Also to develop some advanced analytics on top of this graph. But the subject of this presentation is to implement over 35 validation rules and a data quality dashboard to explore some data quality problems in the ENTSUI data. And finally, we hope that the project demonstrates the benefits of semantic technologies and semantic data harmonization for the electricity domain. This is the project team. As you see, quite a number of people from the Knowledge Graph Solutions team of Ontotext. So what is the ENTSUI transparency data? It is created based on two European regulations. One is on market transparency, the other one on energy balancing. And it includes over 110 data items that describe power plants in Europe, their installed capacity, their current output, wind and solar generation, and a whole bunch of other data. Also specific data about balancing forecasts for generation, consumption, and transmission, and so on. So energy markets and energy traders use this data in their daily operations to decide about their trading strategies. The data can be obtained using a REST API. So these are XMLs that conform to this IEC standard, the so-called market data standard or energy market exchange. But also there are time series data that are bigger amount and they are delivered as CSVs through a secure FTP server. These are the two channels that our project uses. There are some more channels as well. So we have first described the various data items in a semantic way. The name of the data item, the regulation articles where the data item is described, links to the transparency portal and to the knowledge base, and also some flags that describe whether and in what way our own project uses this data. So here you see the semantic, the turtle rendition of the same data. Now, one important aspect are the EIC, energy identification codes, and the various kind of areas that ENTSU operates with. So you have things like synchronous areas, control areas, bidding zones, market balance areas, and so on and so forth. ENTSU jurisdiction covers not just the European Union, but also a few more countries in Europe and also neighboring countries. So this is an overall map of the energy areas in Europe. And here's a more complicated example. Germany, together with Luxembourg, participates in a bidding zone. On the other hand, Germany itself has the role of member state. So you see here, these are the EIC identifiers. EIC doesn't only cover areas, but also market players, energy resources like transmission lines and power plants, and so on and so forth. We'll be seeing a lot of these uh, strangely looking codes throughout the presentation. So in the case of Germany, it is broken up into 4 control areas that are also scheduling areas. On the other hand, together with Luxembourg, it participates in a bidding zone and also in a market balance area. There are 2 transmission system operators in Germany. One also covers the Netherlands, and the other one is only in Germany. So now we come to the specifics of our project. We wrote a very comprehensive specification of what we're going to do and how we're going to do it, also the semantic models and the architecture and so on and so forth. We work at monthly milestones, so you can see here how the specification has grown. We have now put it out publicly, so you could also take a look at one particular example of building a knowledge graph project. And it describes validation rules in such a way that we extract text out of the specification to generate the validation rule implementations in terms of SHACO. Of course, the specification is written in Markdown, but this here is an HTML rendition of it. So now some of the semantic models that we use. Here you see a very simple thing, but very fundamental, the ENTSU code lists that describe all kinds of things. For example, power plant asset type or fuel. Is it a nuclear power plant or a thermal power plant, and so on and so forth. Here is the detailed data about the power plant and one of its generating units with information on high voltage limit, installed output in megawatts, and so on and so forth. Here is the information that comes in the EIC file. So this is basic information, sorry, this is the EIC file, basic information about the name of the resource, the function of the resource or functions. So what kind of a thing it is. Is it a trader, balance responsible party, transmission system operator, a power plant, and so on. And this is an example from one of the time series, or we call them data observations. So these are things that say something happened in a particular control area or bidding zone, and there is a number and a date and a duration. These are 3 of these models put together. So this is the Bulgarian nuclear power plant Kozloduy. This here node is the power plant. This is the Bulgaria market area and member state. This here is the Bulgarian transmission system operator called ESO. So these are the people that provided this data. As you see here, it says provider participant. On the other hand, the responsible participant for the nuclear power plant and the 2 operating nuclear reactors, the generating units, is the company MPP Kozloduy. Okay, this company has a VAT number. And further below, it says that both of these generation units have an asset type which says nuclear power, as well as the overall power station. Of course, the power station and the two generating units have the same type of fuel. You can also see a mistake right here in this data. So on one hand, the power plant says that my two generation units are this one and this one, and this generation unit says my parent resource is the nuclear power plant. But this one has a mistake because it says that its parent resource is the Maritsa East 2 thermal power plant. So we have rules that check the connectivity of the knowledge graph and whether it is correct. Sorry. Here are two more semantic models of time series. So in this case, it is the installed generation capacity aggregated per bidding zone or per country or per control area. And here we have information about outages. So when a power plant or a generation unit has a plant outage for prophylactics or for doing some repairs, or an unplanned breakage, these are very important messages to tell the other market participants that there will be reduced generation from this power plant. Okay, now we come to the validation rules that we have implemented. And these are live links to the specification. So you see 34 of them. They are grouped in various topical areas. So this here is about the EAC file. This one is about the structure of the production and generation units file. There are rules regarding arithmetical relations. Or for example, this one says that we shouldn't have records that say that the voltage of a power plant is 0. If the voltage is not known, there just shouldn't be a record about that. But you shouldn't claim that the voltage is 0. Okay, now to describe one single validation rule, we have all of this descriptive information. What is the group? What is the definition of the rule? What is the name? This here string is also used as the URL of the rule. And it's also an anchor within the specification. So you see later that you can, when you're exploring a rule violation, you can jump right to the specification to read more details. So this particular rule says that the third letter of the EIC should conform to the function as described in a particular document by Ansui. So for example, if the third letter is W, then this describes a resource object, and therefore it cannot be a system operator because the function system operator goes with the letter X, which signifies a party. Or vice versa, a control block must have the letter Y, which signifies an area or domain, and not the letter X, which signifies a party. Out of this, the text of the specification, we extract this part and capture it semantically to feed into the validation mechanism and the UI. And we have further clarifications in the spec about where this rule came from and so on and so forth. And also later on comes the implementation. I'll show you some Shaco implementations. So here is the same rule together with the implementation, which is this here block. So this block, sorry, this part of the rule comes from the markdown, the description, and this part is the implementation, in this case using Shaco Advanced, I mean Shaco Sparkle. So you see some pieces of Sparkle here, okay? This piece finds nodes that violate the rule, and this piece returns extra information, namely which property is to blame. So you see here that the property function is to blame for not being compatible with the AC code. And it also returns some extra information here in the value, namely what would be the what is one of the incorrect values that are present. We use a distinct graph for every shape, for every validation rule, because we need to run the rules not all at once, but one by one. The reason is that there are also data corrections. So after some of the rules, we implement data corrections to make further rules more meaningful, return more meaningful data. That's why we need to interleave validation and correction. This here is the semantic model of capturing rules and violation results, validation results, and an extra class that we defined called validation count. So the validation count is what feeds the front page of the data quality dashboard. It says that for this rule, there are so many violations per zone. Okay. We describe rules using the Shaka ontology. So for example, SHash group is a standard property that serves to group shapes into groups. But we also have some extensions. For example, for every rule, we need to know whether it applies to a country code, a bidding zone, or a control area. We also list all of the data items that are being checked within this rule and which particular fields of those data items. So these are either XML fields or CSV column names. And the implementation of the rule has things like target class or the property that is being validated and so on. So this particular rule says that the parent resource property must be equal to the generation unit property, but only limited to the class generation unit. Okay. And then we capture the results again using a standard class Shaka validation result, but we add here some extra information to allow us to represent the rule in a more useful way. It also captures the value, and we display the value in a nice way. If it's a URL, then we display the notation of that URL and a link so that you can examine the data of the URL. And finally, the count just says on this date, we did some validation according to this rule, and we found 2 violations to be able to display it in a table. Okay, data corrections, I already mentioned. The purpose of data correction is first to make some information more explicit. For example, the third character of the EIC code, we capture it as a separate field called EIC type. There is such a code list distributed by Ansui. We basically link to that code list. Then we also make corrections in the data so that subsequent validation rules can be more meaningful, can return more meaningful data, and so that we do not miss to trigger a rule. And here are the corrections. Basically, if the function of a resource is not spelled correctly or consistently, for example, there is a number that are called generator, but the right function name is generation unit. And then explication of the EIC type, addition of basic EIC info to production units that are missing from the EIC file, and so on. The validation service is implemented in Java. It uses the top quadrant Chaco implementation because we found it better fitting the purposes of the project. And then it invokes the validation rules one by one. It records the validation result from every rule, but then it runs some post-processing because we found that the Shako API doesn't capture in the best possible way the results. So things like making this link, this property point to the node that defines the rule overall, but not to a subnode thereof, to a blank node. it resolves our own property applies to in cases where the rule could apply to more than one kind of area. And another thing here, it's a minor thing. Then it computes the validation counts, which feed the front page of the validation quality of the data quality dashboard. It runs data corrections, and finally it transfers corrected data and validation results back to Gravity. Okay, so here is the data quality dashboard that I mentioned several times. The first part of it displays rules per country code. So you see here, these are the countries that are within the ENSUI jurisdiction, meaning that it knows about sub-areas in these countries and it knows about power plants in these countries. And then there is another group of country codes called Other, and we have some energy resources from other countries, in particular energy traders. However, these do not fall within the jurisdiction of ENSUI. We also have another column called None, because for some violations, the respective resource doesn't carry a country code. And I won't describe every validation rule, but let's take a look at this one, for example, for VAT numbers of energy traders or other market participants. The first one says that if the VAT number has a country prefix, then it must conform to the country code recorded about the same resource. And you see that there is some amount of validation, of violations. The next one says that if there is a VAT number, then also a country code must be present in the resource. The reason, and we'd like to have that in order to check per country format of VAT numbers. Now, one of the corrections adds such a prefix if the country code exists but is missing from the VAT number. So it's this one, this next rule. The majority of VAT numbers have a country code, but there is some amount that do not, and we add it whenever possible. The next one uses an external validation service, namely the VAT information exchange system of the European Union. This is only limited to, I'd say, 20 of these about 30 countries that you see here, but still it's quite an important service. And finally, this one checks regular expressions. So we know that, for example, for Bulgaria, the VAT number is 13 digits. For Albania, it starts with JKLM, and then some number of digits. We check all of that, okay? This here group is regarding this very important field function, whether it is spelled correctly and consistently, whether it is present in the data, and so on. I'll show you some examples for it. Now, this dashboard has three sections. This one is per country code, the next one is per bidding zone, and we're getting here in somewhat more complicated rules. And mind you, this is work in progress. So some of the rows you see here have very few violations, but we're still checking whether that is correct. This one has even 0, but I don't think that is correct. You see here zones that are not countries. For example, in Italy, they have these 6 different bidding zones. By the way, some of these zones were missing from the EIC file, so we added them. They are present on the ENSUI REST API, but not in the EIC file. We have all of this information in the spec. Okay, now here is an example of the validation results of one particular rule. We want the function to be compatible with the EIC code. So here, for example, the EIC code has letter Y, which stands for party, but the TEAS area is not a party, it's a market balance area, and so on and so forth. Also, you see here links or information about which data items are involved in this particular validation, including a link of where we got the data or further description of the data item. And also, in this case, the XML fields that are involved in the validation, the total number of warnings or violations that were found, when was the data validated, and so on. Now, if you click on this link of the resource where the violation was found, you can examine the data right inside GraphDB. And this one presents some curious errors. I comment them on the next slide. Okay, so if you take a closer look, this is a Slovenian market participant, namely the electric transmission system of Slovenia. But first of all, SL is not the code for Slovenia, but for Sierra Leone. Okay, that's why we found this in the other area. Okay, and that's how I caught that. Okay, SL, what is it, Slovenska? But this is not the flag of Slovenia. Something is wrong. Secondly, the description says fictitious area. Okay, but the EIC file is supposed to have only real resources, not test resources. Then it also says we don't have a valid function for it. This comes right from Slovenian data. You also see the notation mentions that it is fictitious. And the last problem is that this particular market participant has another EIC code. And like, is it Slovakia or Slovenia? Okay, I think this is also, this EIC code describes a control block, but is it Slovakia, Slovenia? And one of these EICs must be deleted, right? This one particular entity should not have two EIC codes. So the particular local issuing office that created this EIC code should delete it, should retract it. Now there are somewhat more serious errors. We found 928 production and generation units for which we have information regarding installed capacity and voltage and what are the generation units in that power plant, but we do not have them in the EIC file. And the EIC file is supposed to carry the basic information. So why is it missing? We make a data correction, okay, that adds the basic data based on the data that we have from the production file. Now, this is the converse problem. There is quite a large number of production unit or generation unit, 13,000, that are not described in the production and generation units data. So we know that this is a production or generation units, but we don't know anything about it. What is the megawatt installed capacity? What is the high voltage limit in kilovolts? And okay, the regulation says that the particular item production and generation units only needs to report units greater than 100 megawatts. So if all of these 13,000 units have less than 100 megawatts, then the data providers are not in violation of this clause of the regulation, but still it would be nice to get higher coverage of all of these power plants. Now, here is a very curious case. So, you know that France, the biggest amount of electricity they produce is from nuclear power plants. But then we saw this crazy number of other kinds of power plants. It's like 7.9 million megawatts. And this would solve all of the energy problems of not only Europe, but maybe even the world. But then if you go into the detailed file describing installed capacity per production unit, we see that in the category other, there's just one thing that was installed quite a long time ago, and it has a modest 62 megawatt of capacity. So we have a validation rule that says the aggregated capacity, we are going to compare it against the computed capacity from the individual power plants in that area, and we would like the aggregated capacity to be within a certain bound of the computed capacity, between 100 and 130%. Now, one example of VAT validation. So this is a simple rule. It says that if the VAT number has a prefix, then it must conform to the country code. And you see here a number of violations. These two are simple. So somebody, instead of adding a VAT number, added the word none. But it's better not to have such empty values, right? And then we come to a number of crazy stuff. So this one, Chrysor North Sea Limited, claims to be from the US, but has a Great Britain VAT. How come? Or here, I don't even know what is the country NC, and it claims to have a Dutch VAT number. We also have the opposite, Lithuanian company claiming to have, I don't know what FL is. It's some minor country outside of Europe. Okay. Now, we also run validation against the European Union VAT information exchange system. It only covers the European Union and Ireland, but not Great Britain, okay? And not any other of the maybe 10 more European countries within the jurisdiction of ENSUI. But still it can catch some important issues. So I checked for Bulgaria. There's a company called Frontier Services, and this is the Bulgarian VAT of that company. And Bulgar Transgas, which is a local issuing office for EIC numbers within Bulgaria, says that it is an EIC of international significance, maybe because it is a balance responsible party, yet it is missing from VS. And if you search for that VAT number in Google, you find that somebody says, well, yeah, it has been delisted from VAT. And this happens either because it has unpaid taxes with the Bulgarian tax administration, or for some other reason. There could be even a worse reason. It could have been caught to be stealing VAT. I think this kind of information is very important for the market participants, right? That they should be wary if they have any dealings with this company. Okay, that was the presentation, and now I'll quickly switch to show you. We only have a few more minutes, but it's the last session, so I can spend some time here. So this is the so-called data validation or so-called data quality dashboard. And if you click on one of these here examples, so let's look for Austrian companies that failed VAT validation in VS. In other words, they are not registered for VAT with the European Commission. And if we click on one of these, then we can examine the actual data. Okay, so it's a system operator, BOG, I don't know what that stands for, but it's probably an important player in the, okay, Baumgarten Oberkappel Gesellschaft. And if we search for this in the VS system, so we have to select here Austria, that number is not found. Okay, I don't know the reason. It could be that this is slightly misspelled, but we have the validation of, I think that Austrian numbers are not supposed to start with the letter. Actually, let's check that. So another thing you can do is jump right into the specification. Okay, and somewhere close here we should have the regular expressions per country. Okay, here they are. So it's the rule, the VAT number must conform to the syntax for that specific country. Okay, Austrian numbers are 80, followed by the character U, and then 8 digits. Let's see whether this has 8 digits. Yeah, I think it has 8 digits. So I think this is there is no mistake in this VAT number, but either the number is discontinued in the Austrian trade register, or the company is no longer registered for VAT exchanges, for paying VAT and for receiving VAT, one of the two, right? So I think this is the important thing about our system, that you see an overview of the counts of what is valid, what is not valid. And then when you click on a count, you see all of the violations in a table. And you can click here to see the detailed data about the energy resource. And you can click over there to see the details about that particular validation, including how it is implemented, what correction comes right after it, and so on and so forth. Okay, that was all. Now let me check if there's any questions. The questions are...
Thank you, Vlado, for the presentation. No questions currently, but you still have a minute or so to ask your question if you have any. Meanwhile, I'd like to take just a minute to thank everyone who participated in this event today. And all of the sessions are recorded and they will all be distributed over an email in a couple of days from now. So you can expect that. And yeah, I don't see any questions at this moment, Vladi. I think we can close the session and the event. So
Okay.
any final words from your side?
My email is here at the last slide. So if you have questions, comments, or are interested in this way of validating knowledge graphs, we would be very glad to talk to you. Thanks.
Thank you very much.
Thank
And
you.
thanks
Bye,
for
everyone.
joining. Bye bye, everyone.